In this video, we will discuss regarding design of Yagi antenna. What are the steps to be followed for design of any Yagi antenna? To the design of an Yagi antenna. Okay, so what is meant by this design? Okay, so someone have asked design a Yagi antenna. What is your first? What are the things you want to consider? One has asked you to construct an Yagi antenna. So the things you want to remember is, okay, if I want to construct an Yagi antenna, so in this diagram, this is your reflector, this is your driven element, and these are all directors. These are all directors. Okay, so first of all, you want to know what is the length of the reflector. What is the formula to calculate the length of the reflector? Similarly, what is the length of driven element? And next one is, you want here how many directors are there? This is director D1, this is director D2, this is director D. And again, you want to calculate what is the length of director D1, what is the length of director D2, what is the length of director D3. These are all the things you want to keep in mind. Not only this one parameter, length of all the elements present in the Yagi diagram. Is the other thing you want to consider? How much distance I should maintain, or spacing between, what is the spacing between reflector and driven element? And similarly, what is the spacing between driven element and director 1? And what is the spacing between director D1 and D2? What is the spacing between director D2 and D3? Okay, so these are all the parameters you want to keep in mind while you are designing an antenna. One is length of all the elements present in the Yagi antenna, and the other one is the spacing. The spacing, whatever the spacing that is provided in the Yagi antenna. Okay, the spacing is important. Okay, so generally here we are considering that the length of the driven element, the length of the driven element, we are considering it as lambda by 2. Okay, so lambda by 2. So the length we are considering it as lambda by 2. What is the lambda? Lambda means C by F into 2. C means 3 into 10 to the power of 8. That is frequency, that is 2. So if we convert this, okay, into here, so 3 days 1.5, we convert this. So the length of the driven element, length of the driven element is equal to, we'll get 150 by F in megahertz, that is in meters. So this is theoretical derivation. But coming to the practical, so due to electrical characteristics of the antenna, it is found that an antenna element will be 5% to 7% shorter in practical than those obtained using exact form. So what is the length of the driven element? Okay, so from this explanation, I can say that the length of the driven element, I can write it as 143 by frequency of in megahertz, that is in meters. Okay, so if the length of the driven element is 143, compulsorily what should be the height of reflector? No doubt the height of the reflector is a little bit more when compared to the driven element. Okay, so the length of reflector, I will write it as 152 by F in megahertz, in terms of meters. Okay, so what about the directors? No doubt the directors are always less than the driven element. Therefore, length of director T1 director D1, it is given as 137 by F in megahertz, that is in meters. Okay, so similarly, length of director D2, length of director D2. So it is 133, 5% less, 5% less in megahertz, this in like this. So these are the formulas for length of driven element, length of reflector, length of director, one director, two. Okay, these are all lengths. Here you are expressing in terms of meters. Here you are expressing in terms of meters. The same thing if I express in feet. If I express in feet, the length of the driven element is 475 megahertz in terms of feet, and length of reflector is equal to 500 by FF megahertz in feet. Length of the director is equal to 455 megahertz in feet. Okay, you can use this in meters, and if you want to express in feet, you can use this. You can use this. Okay, so these are all lengths. What about the other parameter we want to consider? The other parameter we want to consider is, okay, spacing. What should be the spacing between reflector and driven element? What should be the spacing between driven element and directors? Okay, so similarly, the spacing between the first one, reflector and driven element, the spacing between or separation distance between a reflector and a driven element or dipole, it is given as 75 by F megahertz meters. Okay, so similarly, separation distance or spacing between driven element and the director D1, driven element and the director D1, it is 40 into F megahertz. This is also meter. Similarly, the separation distance between director T1 and director T2. Okay, so it is given as 38 by F megahertz, that is in terms of meters. So this is regarding length of elements of Yagi UDA antenna. This is spacing between the different parameters in Yagi UDA antenna. Okay, let us solve one problem based on the Yagi UDA antenna. There's a design of an Yagi UDA antenna. The question is like this. Design an Yagi UDA antenna of six elements to produce a gain of 12 dB operating frequency at 200 megahertz. Okay, so solution. Okay, so how many elements are there? They have told that totally 6 elements. 6 elements means first divide that. What are the 6 elements? We will have only one reflector, one driven element, or we can call it as dipole. One driven element or dipole. 2 completed. Remaining how many directors will be there? 4 directors. 4 directors. Okay, so one reflector, one driven element, and 4 directors. Okay, now let us see here. What is the first one? Let us calculate the length of the reflector. What is the formula for the length of the reflector? It is 152 by F megahertz into meters. This is the formula. So it is 152 by 200, that is equal to 0.76 meters. So what is the length of the reflector? It is 0.76 meters. Next. length of the driven element. Next one is length of the driven element. What is the formula? 143 by F H into meters, that is 143 by 200, that is 0.715 meters. Next, length of director D1. Length of the director D1 is equal to 137 by F H meters. So its value is 0.689 meter. If we observe here, always the reflector will be more when compared to driven element, and the driven element will be more when compared to the director D1. Here, how many directors will be there? We have 4 directors: D1, D2, D3, D4. No doubt D1 is more height when compared to D2. D2 is more a little bit more when compared to D3. D3 is more when compared to D4. Okay, now we have completed up to director D1. Okay, let us complete length of director D2. Length of director D2 is 133 by F in megah meters. That is 133 by 200. That is 0.665 meters. Next, length of director P3. So it is 130 by F in megah meters. So it is 130 by 200, that is equal to 0.65 meters. Okay, next, length of director D4. So length of director D4 is equal to 126 by F in megah meters, that is equal to 0.63 meters. Okay, so these are all the things. Totally 6 elements are there. What are the 6 elements? This is the first element, second element, third element, fourth element, fifth element, sixth element. Okay, now we'll calculate the separation. Okay, so coming to the separation distance between first one is a reflector and driven element or dipole. Driven element or dipole. The separation distance is 75 by F megah into meters. So 75 by 200 gets 0.375 meters. Next, separation distance between driven element and director D1. Director D1. The form is 40 by F megah that is equal to 40 by 200, that is equal to 0.2 meters. Next, separation distance between director D1 and director D2. Okay, so it is 38 by F megah equal to 0.19 meters. Similarly, separation distance between D2 and D3. This formula is 35 F megah. Okay, and similarly, D3 and D4 is 31 F megah in meters. Okay, so now we'll summarize all these values and we will draw the diagram. We'll summarize all these values and we will draw the diagram. Okay, we will draw the diagram. Summarize this diagram. Okay, so now tell me what is the length of the reflector? Length of reflector is equal to 0.76 meters. Okay, next. Length of driven element is equal to 0.715 meter. Director T1 is equal to 0.685. T2 is equal to 0.665 meters. All are in meters. All are in meters. T3 is equal to 0.65 meters. D4 is equal to 0.63 meters. Okay. Similarly, separation distance between reflector and driven element. It is 0.375 meters. Driven element and T1. Okay, it is 0.2 meters. And T1 and T2 is 0.19 meters. Similarly, T2 and T3, it is 0.11 meters. And similarly, the separation distance between 16. Okay. T3 and T4, it is 0.12 meters. Okay. So by taking all this one, we want to draw the diagram. Okay, so we want to draw the diagram. So this is my reflector. So what is the reflector height? Reflector height is 0.715 meters. So this is my reflector. Next, driven element. Next one is driven element. This is your driven element. So the height of this driven element is 0.689. Next, director one. This is your reflector. This is your driven element. This is your director D1. What is the height of the director D1? The height is 0.689. And similarly, D2. So what is the height of the D2? The D2 height is 0.665. And next, what is the value of D3? The value it is 0.65. Next, D4, the height it is 0.63. Okay. And the other thing you want to keep in your diagram, that is separation distance. So what is the separation distance between these two, director and driven element? It is 0.375 meters. Similarly, what is the separation distance between driven element and this one? This is 0.2. Similarly, what is the separation distance between D1 and D2? It is 0.19 meters. Similarly, what is the separation distance between this one? 0.16. Here the separation distance is 0.1. So this is the design of Yagi. This is the design of Yagi antenna. Okay, so you want to calculate the length of various elements present in the Yagi antenna and the separation distance. The separation distance. And the separation distance you want to calculate